enveloped polyhedral virus looks like, know what an enveloped helical virus looks like, and then be able to identify the pieces. So draw it. If you want, oh, that's what I was gonna go out and get our, forgot this in my car, our whiteboards. But so draw them on a piece of paper and identify the area structures are and what they're made out of. And then one more chore to do is from the central dogma, DNA to DNA. This is like bacterial, what we've talked about so far, how DNA replicates, and then how DNA, what enzymes are used to make RNA, what enzymes are used to make proteins. That's a good review. And then what a class 1 would use, what a class 3 would use, and what a class 6 would use. And we didn't go through all the classes, but the reason I like to bring these up is because it brings up our weird viral enzymes, and it also kind of makes you think of like, okay, how does the virus replicate, and then how does the virus make new virions? So I'm just gonna go run out and grab our little whiteboards really quick. I'll be back in 2 seconds. Double-stranded RNA, how does it replicate its genome? If it goes from RNA, how do you get more RNA from RNA? From a replicase, does that make sense? Yeah?
So the stuff we learned from choosing and
Yes, yes, yeah. So it'll almost be like a viral quiz portion of the midterm. So,
but it's mainly gonna be like about bacteria.
I would say, yeah. I mean, mainly, but there's kind of like a whole viral section for sure. Yeah, because I haven't gotten a chance to ask you about viruses yet, so it'll try to be quiz style. Yeah. Oh, yes, yeah, I haven't really gone over that, so I can talk to you about that. So do you guys feel comfortable with this? I can go over that too. But, yeah.
So class 3 has double-stranded RNA, and it's making its own RNA with the replication carries within its RNA.
Yes, it's making its own RNA from its own RNA. Okay, so if you go,
I put cardiac, and now that I think about it, it's good.
Oh, we haven't done that yet. We've done
How long does it?
We're on
so I haven't really gone into this yet because we haven't talked about eukaryotic DNA and RNA, but in a eukaryote like us, there's a 5' cap and a polyadenine, a poly A tail on when RNA leaves the nucleus. So this is how it is in our genome. But a negative sense would be the 5' and 3' cap, which is like a methyl group.
Oh, okay.
So it's arranged backward, and our RNA polymerase or ribosomes don't read in a backwards way. So it would assemble the amino acids backward because it would have a start codon over here. And if it has a start codon here, it doesn't assemble that way. So it has to go to a normal, so it needs some way to go to a normal positive sense RNA. So it has to be able to, so if you see right here, so if it has double-stranded RNA, it will go to a normal RNA because it has both RNA strands. It has a positive and a negative sense RNA because it's double-stranded.
So is one strand like just caps and one that goes
single-stranded tails, this one has a capsule, the other is just.
Yeah, so they're opposite. Yeah, so the methyl group, or I don't want to say methyl group, the methionine start codon is at the wrong tail on a negative sense RNA.
And if it was a single strand and it was at the wrong side, what would it use to get to the human?
So then it would need a replicase.
Or need a replicase?
It would need a replicase to get to the positive strand. Yeah.
And that replicase will use ribosomes?
So the replicase reads RNA and makes more RNA. So it's gonna read the negative RNA and make more RNA.
Does it make positive
In the
RNA?
right order.
Positive sense. Okay,
Yes.
positive sense being human orientation.
Yes, yes, yeah. And I didn't go into that too much because I didn't want you guys to stress about it, but as long as it makes sense to you.
Yeah.
Yeah, that it's so we have positive, we just call it positive, because like why label us being, we're positive, right? So this is how we would normally have, so this is the AUG start codon over here, and this is some sort of stop codon over here.
Is that AUG start codon a methyl group that's part of the cap, or is it after?
It's after.
After, okay. So the methyl group is not nucleotide.
Yeah, so here would be, the ribosome would start and add a methionine here.
Okay.
So this is where if this is a positive sense.
Yeah.
If it's a negative sense,
3 to 5.
the AUG would be here. So if the ribosome attached here, it would go that way. And then it would just fall off. Like
So you're
there-
saying
it
the
would-
negative
it would be
one-
one methionine long, the amino acid. So it would have to go this way, but ribosomes don't do that.
So ribosomes can't work with negative RNA.
No.
Is there a function of negative sense? Because it's weird to imagine the start
why is it
codon
there?
being an end.
What I would guess, the reason, this is just total wild guess, is that it's like a safety mechanism. So that it's almost like having the extra copy. So
It's
that
like a
that
DNA
extra
kind of.
copy- Yeah, it's almost like having that extra security layer, so that layer will be transcribed, or not transcribed, it'll be translated correctly, is what I would guess.
Oh, okay. So it can be reversed, similar in that reasoning for security reasons, so that it's like encrypted or something almost where nothing can really read it because it doesn't make sense that the start codons are different.
Yeah, and also, things have a hard time getting into the nucleus of our cells. And if it's DNA, it has to get into the nucleus or it'll get degraded because DNA isn't on the outside of the nucleus.
Right.
So it's maybe something like that, it's just my guess. I don't know.
Okay.
Oh my gosh.
Does that, last question on this.
Yeah.
On our COVID note card, it says, it specifies specifically that it's positive sense single-stranded RNA. Does that mean something to like neurologists or epidemiologists or something that positive sense, does that have some kind of like tangible, traceable health impact?
You know, maybe for somebody that knows viruses better than I do, it would be like, oh, if it's a positive, well, automatically you would know it has to come with its own replicase or reverse transcriptase.
Okay.
So from there, then you're like, okay, well, how rapidly does it divide? You know, how rapidly does it mutate?
That could narrow it
That
down.
kind of thing, yeah, is what I guess, yeah.
I was just gonna make a comment.
Oh, yeah.
I went down a virus, like,
Cool.
loophole thing.
Yeah.
And I am choosing a side that they are not living.
Awesome.
And
Choosing a
I think
side.
everyone should have to choose.
Love it. So we should have to stand to one side or the other.
Yeah.
Awesome. Man, I would go on the living side. I don't know,
It's just gene though. It's just floating around.
yeah, it's just
How are we
genes that,
living this time? What's the metric of using the differentiation?
right.
Okay, well,
like-
They have like.
it's almost like it's just a process.
Well, aren't we